Our next topic is one of the areas that is, at the same time, one of the most powerful things about Ruby, and also one of the things that people new to the language get a little tripped up on, because they're features that are not nearly as common in other modern languages that most people are using. Certainly not so in Java, a little bit in Python, but even there, not so much. So let's talk about blocks and iterators and some of the functional idioms that they enable. Functional programming, if you had the good fortune to take a course that no longer really exists here. It's called Structure and Interpretation of Computer Programs, and it used to be taught in a language called Scheme. And that course, among other things, had an introduction to a really deep idea called functional programming that has been in the languages community for a long time, and some people, including me, think it doesn't always get the airplay that it should. And what we're going to talk about in the next few minutes here is how can techniques from functional programming actually help us rethink some pretty basic programming concepts, like, for example, iteration, something we do so often we take it for granted. We do for loops, we traverse data structures, and more importantly, why should we care? Why is it worth rethinking our approaches to some of these pretty fundamental programming constructs? So let's just start out with some examples. And as usual, you'll get used to seeing the examples, and you'll quickly come to realize, as you use the language more, why these are valuable things that you can do. Here's a collection of three things. An apple, a banana, and a cherry. It's just an array of three strings. And I can say, with each string, just print it. So that looks like a loop, right? The tendency, if you come from an imperative language like Java, is to say, oh, I get it. That's like a way of writing a for loop over the array elements. It's not. Take it on its own merits. It's each. Here's a collection, and with each element of the collection, do something. Let's do a couple of more examples to drive that home. You could do this, but that's really just syntactic sugar for something that's more like this. Right? What's going on here? What is this up to business? Well, we know it's a method call. We know it's a method call on an integer. We know it's a method call that takes one argument, and it can be followed by a block. A block is just a lambda expression. It's a procedure that has no name. In this case, it's a procedure of one argument, num, and what it does is just print out that num. But really, that's what it is. It's a procedure. It's a function call, and what I'm really saying is, I'm going to generate a list of numbers, and for each one of them, I'm going to call a function passing that one thing as an argument. Here's another shortcut that Ruby provides, rah, rah, rah. I've also, in this case, substituted braces for do and end. Less common of an idiom, but sometimes you'll see it. So don't be too confused. Whoops. There we go. Sorry about that. Don't be confused if you see the idiom of substituting braces as opposed to substituting braces for do end. So what's going on in all these other examples? I mentioned this briefly in a previous lecture, but what all these examples have in common is that we're allowing the objects manage their own traversal. So in this case, we have a range of objects, the integers 1 through 10, and we're saying traverse yourself, and for each element that you give me back in the traversal, I'm going to provide a function that you call with that element as an argument, an anonymous function, an anonymous lambda expression. Your friends will be really impressed if you use that word regularly in conversation. They'll also stop inviting you to parties, but whatever. So that's an example of range traversal. Well, what about this thing with arrays? Well, we saw that we could take an array and say, for each element in the array, again, I'm going to give you a function, and you're going to call that function with each of the array elements. So what's interesting between these is that you have no idea as a programmer internally what mechanism is being used to grab each element and provide it to you. You're giving that responsibility over to the target. You can do a similar thing with hashes. Remember that hashes have keys and values, so there's actually a couple of different constructs provided for going through the key value pairs. You can say for each key, give me that key and do something, or you could say for each key value pair, because the anonymous function can take more than one argument. It could take 0 arguments, in fact. Again, the simple example I gave before, 10.times, well, that's really just a shorthand for something like this, right? Except that it's an iterator of arity 0. It takes no arguments, because if you're saying 10 times, presumably you don't care about the value of the index. If you cared about the value of the index, you would do something like one of these first cases. So what this leads to is something that a lot of Ruby programmers call expression orientation. You don't think in terms of, I'm going to do something to this collection. Instead, you think in terms of, hey, collection, I'm going to ask you for things, and I'm going to do things to your elements. So for example, I can have a collection X, which is just an array of strings, and I can say, sort yourself. I can say take your unique elements, which, by the way, what does that do? It returns a new copy. So x is not being modified here. No x's have been harmed in the preparation of any of these examples. I'm getting a new copy, which is x with the replicated elements removed. And then I'm going to reverse that. So I get banana, cherry, apple. There are versions of some of these that are dangerous. Remember I said that sometimes if you see a function name that ends with bang, it means this function is dangerous, or it may have side effects, so use with care. So in some cases, like reverse, there is a variant that ends in bang that does modify the receiver. So x reverse bang, or x reverse, actually means x will be modified. There's also map. If you've used language like Python or even Scheme, map is for each element of the array, I'm going to do something to each element, and the result is to return a new thing. So whereas the result, before when we were traversing the elements, we were just saying, here's a function call, and it's going to do something with each element, map goes further and says, actually, the result of the overall map is a new collection in which each element has been, in which each element is the result of calling that the anonymous lambda. So in this example, I take my original collection of fruits, and for each element in the collection, I'm going to call reverse, which reverses a string, returns a new copy of the string with the elements reversed. So the result of this intermediate step is just an array in which each of the words has been individually reversed. Oh, and by the way, since the result of the overall map is itself a new collection, I can call sort on that. So what you'll see in Ruby is you'll see A.B.C.D. You sort of build up a list of things you want to do. It's almost like a Unix pipeline. But the idea that everything returns a copy of something, it has a value, it evaluates as an expression, and then you can continue to do more things on that expression, that way of thinking really comes from functional programming. And we're going to see some cases where it's very, very useful. Here's another one that Ruby provides, collect, which says, give me every element of your collection, and I'm going to collect all the elements for which this function returns a true value, right? And one thing that you can test for is whether a string includes a character. You can test whether an array includes a character. In a moment, we'll talk about why things like include seem to work all over the place with many different classes. I can ask, is it the case that any of these elements satisfies a particular condition? There's a real-life example that I would suggest you check out offline, because I don't want to take the time to walk through it in this video. But just to give you a preview of it, I'll just show you the code. We're not going to walk through it in depth right now. Anybody have a Clipper card who lives in the Bay Area? It's your public transit card, and you can check your balance online and things like that. And I wanted to write a script that would basically let me go to a single URL and check my balance without having to log into their website, which I'm not a huge fan of. So I used a library called Mechanize, which lets you write scripts against a remote web server. And I created a new Mechanize object. I post to the URL of the Clipper site with my username and password. And notice the dot at the end of every one of these lines. This is all one line, right? Remember I said A.B.C. I'm calling a variety of different methods to build up this expression. So I'm posting a form. The result of posting a form is whatever their site sends back. Then I'm going to look for a link that has this href, click on that link, parse the resulting page, looking for these HTML elements, go to the first row of the table, go to the second, third column, and look for content that matches a $ followed by a decimal amount, and return HTML. That's one statement, kids. Okay? Now, I'm not saying that was beautiful code. Don't get me wrong. I needed something quick and dirty that would work. But the fact that I was able to write that in such a compact way is really what I'm talking about.